Hey guys, it's me again. We're going to be doing a 6th grade spiral practice. So I want you to really stick with me. If you need to take a little break during this time, then that's fine. But these are things that we really need to be thinking about, various math concepts, and these are some things that we've learned in 5th grade as well. So I want you to really try to stick with me and make some connections and write some notes. Okay, notes are very, very important. I hope that you're keeping good organized notes and information. That is so important. Okay, well, here's a vocabulary word for you. Let's look at the question and we'll talk about the vocabulary. It says, which of the following situations would yield data? What that means is when you yield data, that sounds kind of professional, but what we're doing is just collecting data. If you collected data, which one would get you data with something called variability? Now, variability is something we'll talk about all year. Last year, we talked about variables. Those are mystery numbers that are represented by a letter. For instance, we talked about X and we talked about Y. We'll talk a lot about that this year. Those are called variables. They're like mystery numbers or things that change. That's the biggest key to understanding the word variable. Variable means that it changes. Okay, the word vary, V-A-R-Y, means change. If situations vary, like when you watch the weather, okay, they'll talk about the weather being variable, or they'll say that the weather is going to vary throughout the day. That's not the word like I am very cold. That's V-E-R-Y. That has some emphasis. It sounds the same. It's called a homophone. It sounds the same, but it is not the same. This means change. So when you have variable, if something is varied in color, for instance, that means it's changing. So like a rainbow is varied in color. Okay, so enough about that. Variable means changes. Okay, so which of the following situations would yield data with variability? That means that we will see changes in our results. Okay, so let's look at the first answer choice. It says, how many nickels are in $6? Well, think about that. Would that answer ever change at all? I mean, aren't nickels exactly 5 cents a piece? And $6 is $6. So if you were only counting nickels and you were making $6, would that answer ever change? No, it would not change. Oh my goodness, my dog is caught up in my cord. Okay, Marco, come on now, boy. All right, sorry about that. Okay, so how many students, so this would not be the correct answer. That will always stay the same. Okay, let's look at answer choice B. How many students in Mr. Jones' 5th grade period have the last name that start with S? Well, unless you start getting new students and that kind of thing, it will absolutely stay the same, right? I mean, you have exactly the same number of students in one particular day, it says today, that have the last name that starts with an S. That does not change. If you are looking at one particular day, that information is going to most likely stay the same. So that will stay. Now let's look at C. It says, how many students bring their lunch each day? Now let's think about that. You know, remember last year we had to take lunch count and that kind of thing. And, you know, normally I would just send the ladies in the cafeteria the number 17, but was that exactly correct every single day? Not necessarily. No, I mean, you might have a Chicken Smackers Day or barbecued chicken or Taco Tuesday or Pizza Day. Or my favorite was always Fried Chicken Friday. Well, you might have a ton of people bringing their or not bringing their lunch that day because they want that Fried Chicken Friday. Okay, so those things change on a daily basis. So I'm going to put a little dot beside that because that sounds like something that would potentially change every day. That's like going to the grocery store, right? Do you ever just buy exactly the same thing every single day? Most likely not, okay? And a lot of times prices change. So if you're buying strawberries in the spring versus strawberries in the fall, those things, those prices change depending on what season it is, if it's strawberry season or if it's not. Okay, oh, my dogs always decide to play when I'm recording a video. Okay, so the last one, Marco, how many students in our 5th period class, math class, completed their homework on January 27th, 2014? Well, that's a piece of history, right? That's a long time ago. Can that information change? No, it's Marco, hi. It's happened in the past. So that's not going to change. That is exactly the same all the time. If it was 2022 and we asked that same question about January 27th, it'd still be the same. So this is the one that has a change. How many students bring their lunch each day? Okay. Marco is very unhappy this morning. Sorry about that, guys. Okay, the next question, it says, which fraction is equivalent to this number right here? And let's think about another vocabulary term. Equivalent. Oh gosh, I forgot some letters there. This has not been my morning. Okay, equivalent. Okay, it means equal to. So if we write this number is what? It's 8/10. If you say that out loud, it sounds like a fraction because it is. A decimal number is another way to represent a fractional part. So 8/10. Let's figure out, just by reasonableness, maybe there are some answer choices that would never ever be possible. Okay, so let's think about the fraction 8/10. 8/10 is almost the entire whole, because if you have 10, oh, that's an awful looking fraction bar. 1, 2, 3. Okay, so if you have 8/10, all right, that's 1, 2, 3, 4, 5, 6, 7, 8. That's almost the entire fraction bar. It's almost complete. 8 out of 10 is almost complete. Well, let's think about 1/8. If you have this same size fraction bar, because whenever we compare fractions, we're always talking about the same size whole. There might be different size parts, but we have to always start off with the same size complete whole unit. Okay, so there are 8s. Those pieces are a little bit larger. I'm not a computer, so it's hard for me to draw exact, but 1/8 is just this teeny tiny little guy. Would those ever be equal value? No, that does not make sense whatsoever. Okay, let's look for another one that may or may not make sense. Let's look down here, 8/9. Well, 8 out of 9 is almost complete, just like this one is almost complete. 4/5 is almost a complete whole. If you have 4 out of 5 parts, you almost have the entire whole. And then let's look at 3/8. If you only have 3 out of 8, we already have 8s over here. That would be 1, 2, 3. That's less than half. Half is here. That's less than half. This is more than half, isn't it? So this would not make sense. So we're looking at these two as possible answers, right? Okay, so let's start using some math to find out what's equivalent to 8/10. So let's compare it to 8/9. We want to find one that's equivalent using math. Okay, we could use models, but let's use math. Okay, do you remember in 5th grade when we said, okay, we can multiply a numerator and a denominator by the same value, which in fraction world represents 1 whole. Anytime you multiply a number times 1 whole, you get that same value. Well, in fractions, those numbers can be different, but they can have the same value. Okay, but you'll end up with the same value. Well, 8 times 1 is 8. But you'd have to multiply this fraction by 1/1, which equals 1 whole. And is 10 times 1, 9? No, that part is not correct. So these are not equivalent. And if you think about it, these amount of parts, your numerator is always what you're focused on. So over here we have 8 that we're focused on out of 10. Well, would that ever be equal to the same size parts? No, because 9 is a different whole unit, right? 9 parts would be a completely different size pieces. So those could never be equivalent anyway. So that's not going to work. So we're hoping that we can prove with math that 4/5 is the correct answer. So let's write this down. I hope you're doing this with me. If you're not able to, and I'm going to put the PDFs on here, but if you're not able to download the PDFs, I've had a lot of technology problems last night, then just write these down in your, on notebook paper in a spiral or your composition book. Okay, so we're going to compare this to 4/5. All right, so let's see. If we can multiply or divide this fraction by 1 whole, which in fraction world is represented by the same numerator and denominator, right? Then we can, if we can do that successfully all the way across and show that relationship, then they are equivalent. Okay, so let's look. We're decreasing in value, so we must be dividing. 8 divided by 2 is 4. Well, we're going to have to see if this works. Would 10 divided, because this represents 1 whole, any number divided by 1 equals that same value. Well, 8 divided by 2 is 4. 10 divided by 2 is 5. We can also use the inverse operation, multiplication, to check. 4 times 2 is 8. 5 times 2 is 10. Awesome. Now this is review. You did this in 4th grade and in 5th grade, so I'm hoping that I'm not moving too quickly, but go ahead and you can always replay this and just slow it down and think about it. You can practice a few. But this is equivalent. Those show equal value. So awesome, awesome. I hope that brought back some memories for you. Okay, now this last one's going to be a little tougher. All right, you know, I think I'm going to save this for later. Okay, this gets into dividing fractions, and that's a completely different story. We need to go over that all in a separate setting. So let's just go ahead and stop this spiraled review right here. Thanks for sticking with it, and I'll see you on a little bit for multiplying decimals.